Okay, this is the 2016 AP Calculus practice exam. This isn't the actual exam that I've made other videos for. This is the practice, the official practice exam. And I'm going to, in this video, work multiple choice numbers 1 through 15. And this video is specifically for the 2020 test. As we go through these problems, if we get to one that's not on the 2020 test, or I don't think it'll be on there, then I'm going to tell you why. Now, the 2020 test is going to be free response, probably 2 free response questions, but I think it's worthwhile for me to work some multiple choice questions because it still gives you practice on things that are going to be on the test. So I'm going to work this entire test, both multiple choice and free response, over a series of videos, and when we get to one that I don't think will be on the 2020 test, I'll explain why. So you know you've got the right test if number 1 it asks you to integrate from -1 to 3 of x squared minus 2x dx. So the antiderivative of this would be 1/3 x cubed minus x squared, and then we have to plug in the limits of integration -1 to 3. So this is going to be 1/3 times 3 cubed minus 3 squared minus, let's put a bracket, and then we would have 1/3 times -1 cubed minus -1 squared. So we've got to be really careful with our signs here. 3 cubed is 27. 27 over 3 is 9. Minus 9 minus -1/3, because -1 cubed is -1, and then -1 squared is 1, so minus 1. So that's 0 minus -4/3. Minus minus makes a plus, which is positive 4/3. So that is answer B. All right, so that's one that's easy to mess up all the signs on. Okay, so there's number 1. I think that one, something like that, could be on the test. Okay, number 2 says f of x is equal to e to the 2x times x cubed plus 1. What is f prime of 2? All right, this is product rule. So f prime of x is going to be the first, e to the 2x, times the derivative of the second, 3x squared, plus the second, x cubed plus 1, times the derivative of the first, that's e to the 2x, times 2. So let's plug in a 2. That's e to the 4th, 2 times 2 is 4, times 12, plus, okay, that would be 2 cubed, which is 8, so plus 9, times 2e to the 4th. So that's 12e to the 4th plus 18e to the 4th, which is 30e to the 4th. And that is option D. Okay, so the first 2, those are pretty good practice. I think I can fit number 3 on my whiteboard here. So it says we have a function such that f of 2 is equal to 4. F prime of 2 is equal to -1/2. What is the approximation for f of 2.1? So we have to get a tangent line equation. We know that the slope at x equals 2 is equal to -1/2, and we have a point here. We have y minus y1 is equal to the slope times x minus x1. So that would be plugging in the 0.24, y minus 4 is equal to -1/2 times x minus 2. So y is equal to 4 minus 1/2 times x minus 2. So f of 2.1 is going to approximately equal to 4 minus 1/2 times 2.1 minus 2. So that's 4 minus 1/2 times 0.1. So 4 minus 0.05, which is 3.95. Okay, so that is option B. All right, definitely going to have to, I could definitely see you have to approximating using the tangent line approximation. That one is just, I really feel like you could have to do that on the 2020 test. Okay, number 4. So we've got g of x is equal to x to the 4th plus 4x cubed. How many extrema does it have? So how many maxes and mins? All right, well, to get that, we would have to take the derivative. So that's 4x cubed plus 12x squared, and we set that equal to 0 to get our critical points. Let's factor out a 4x squared, and we're left with x plus 3 is equal to 0. So our critical points are at 0. That'd make it 0, right? So 0 and -3. So I'm going to do a sign line and see if 0 and if we have maxes and mins. There, so -3, 0. Let's plug in, I don't know, -5. That's going to be positive because you're squaring it, times a negative, so negative. Let's plug in something in between there. How about -1? Positive times positive, so that's positive. And for something to the right of 0, how about 1? All right, that's also going to be positive. So we have a minimum at -3, but no max at 0. So you only have one extrema. So that is option B. Okay, so you have to go through the sign line thing, because just because it's a critical point at 0 there was 1 doesn't mean it's an extrema. Okay, so it could be that the slope just flattens out at that point and then it goes back north again. All right, we're doing great. So 1 through 4 is done. Let's look at number 5. Okay, number 5 says the velocity of a particle moving along the x-axis is given by v of t is equal to 2 minus t squared. For time t is greater than 0. What is the average velocity? Well, the average velocity, and I feel strongly that you might have to do an average. All right, it's 1 over b minus a, okay, and we're wanting to know in this problem from t equals 1 to t equals 3. And you integrate the function, v of t dt, from a to b is where we evaluate it. Okay, so that's 1 over 3 minus 1. We're going to integrate from 1 to 3, 2 minus t squared dt. So that's 1/2 2t minus 1/3 t cubed. We're going to evaluate that from 1 to 3. So 1/2. 2 times 3 is 6 minus 9, right? 3 cubed is 27. Divide that by 3 is 9. Minus 2 minus 1/3. All right. So that's going to be -3 minus, All right, 6/3 minus 5/3. So that's 1/2 times negative 14, because that'd be 9/3, right? Negative 9/3, so negative 14/3. Half of that would be negative 7/3. And thank goodness that's one of the options. That is option C. All right, a lot of course you will have your calculator, and you can always put this in your calculator on the 2020 test. All right, number 6, it's asking us to approximate the number of tons deposited at a recycling center using the trapezoidal sum. All right, so don't get scared off by trapezoidal. It's really easy. So I'm going to go ahead and take the time so that I can show you and reproduce the table here. Okay, so a trapezoidal sum, so you can think of this is the base and this is the height. So we've only got 3 that we have to figure out, 3 trapezoids. The area of a trapezoid is equal to the base times the average height. Okay, so the total here, so we're going to sum the areas up. The base for our first trapezoid is 2, 0 to 2, and then the average height would be 15 plus 9 over 2. All right, 15 plus 9 divided by 2 gives us the average. What's the second base? What's the base of the second trapezoid? Well, 2 to 7, that's 5. And then the average height would be 9 plus 5 over 2. The base of the third trapezoid is 2, 7 to 9. And the average height would be 5 plus 4 over 2. Okay, so the 2's cancel, you'd get 24. 9 plus 5 is 14 over 2 is 7. 7 times 5 is 35. Then the 2's cancel here, and you would just be left with 9. Okay, so that's going to be 33. 9 plus 24, 33 plus 35, 68. And that is option A. All right, so you might get a trapezoidal one. They could give you one, and that's how you do it. It's not that much harder than a rectangle. If you did a rectangle, of course, you would just be using the left or the right, or you could be using the midpoint sum, where you would take the average between the two. So really, in a lot of ways, this is the same thing as a midpoint sum on a rectangle. All right. Number 7. Number 7 is not on the 2020 test. So let me tell you why. It's because they're trying to find the area between two curves. So that cuts off. Okay, that the test cuts off that last chapter that we did. So no areas between curves. Any other year, of course, we'd work this one. All right, let's try number 8. That one says the function g is defined by g of x is equal to x squared plus bx, where b is a constant, if the line tangent to the graph of g at x is equal to -1 is parallel to the line that contains the point 0, -2, and 3, 4. What's the value of b? Okay, so what it's saying is that we need to get the slope of this line because it's going to have the same slope as the tangent line at x equals -1. Okay, so this slope is going to be the change in y over the change in x. 4 minus -2 over 3 minus 0, so that's 6 over 3, which is 2. So that's going to be the slope of the tangent line. We know that g prime of x will give us the slope of the tangent line. That's 2x plus b. That has to equal 2. So at x equals -1, we would have 2 times -1 plus b is equal to 2. So b is equal to 4, which is option D. Could have something like that. Absolutely. It might be written in a free response format. It would be part A, B, C, or D of something, but I think it's worth doing. All right, let's look at number 9. Number 9 is a little bit tricky. I think it's worth working. So we've got this function, absolute value of x over x and 0. This is for x is not equal to 0, and this is for x equals 0. Okay, so x over x would, let's say for x less than 0. Okay, then let's pick a number. Let's just say -1, the absolute value of -1 over 1. So that's going to be, over -1. All right, so in this one, we're picking x equals -1 to try. So that's going to be 1 over -1, which is -1. That's going to be true for any value. So you'd have -5, absolute value -5 over 5 would still be -1, okay? And for when x is greater than 0, so let's just pick x is equal to 1. Then you're going to have the absolute value of 1 over 1, which is 1. Okay, so if we want to evaluate, okay, it asks us to evaluate -5 to 3 of f of x dx. The way we're going to write that out is from -5 to 0, we're evaluating, because that's negative, right? -1 dx. Plus from 0 to 3, when it's positive, it's going to be 1 dx. So that's, integrate that, you'd have -x from -5 to 0 plus x, right? The antiderivative of 1 is just x from 0 to 3. All right, so that's going to be -5 minus, sorry about that. Do the top one first. So that's going to be 0 minus -5. All right, so kind of confusing. Plus 3 minus 0. All right, 0 plus -5 is -5 plus 3 is -2. All right, so that is option A. All right, so maybe back up and watch this one again if you need to, but it's not that hard if you figure out, the integration part is really easy. It's just, okay, I've got to figure out what is the function when it's negative and what is it when it's positive. When it's negative, it's -1. When it's positive, it's 1. And then we just got to evaluate the negative part and the positive part. Okay, that was number 9, that last one. So here's number 10. We have a U-substitution. This one's a little different than the U-substitutions we did in class. I'm going to go ahead and work it for you. I kind of feel like one won't be like this on the test. But we want to know G of what is it equal to? What is G of 2x minus 1 equivalent to? Okay, so if we let u be 2x minus 1, du is equal to 2 dx. So half du is equal to dx. So you're going to have a half, and you know it would be g of u du, right? But the limits of integration on this one change because you have to plug in a 2 into 2x minus 1. So 2 times 2 is 4 minus 1 is 3. And 3 times 2 is 6 minus 1 is 5. Okay, so that's going to be 2 times 3 minus 1. And this one is 2 times 2 minus 1. The limits of integration change. So it would be very easy to accidentally pick B. But the actual answer is D. I don't want to confuse you on this one. Maybe I shouldn't have even worked it. But I don't think you'll have one like this on the 2020 test. But I wanted to go ahead and work it for you. Okay, number 11. 11's a pretty cool one. So what we've got is a semicircle below the x-axis, all right? And we've got this is -6, and the top of the semicircle is at -1, and that value is 2, and this value right above that point is 12. And we want what is the value from 2 to 12 of f of x dx. Okay, so what you have to do is find the area under the curve. So the whole area, we're only worried about finding this part in red. That's the area under the curve. So, or between the curve and the x-axis. So what we've got to do then is subtract out the entire rectangle. So we're going to get the whole rectangle and then subtract out the area. So what is the area? Get a different color here. It's blue. What is this area here of the semicircle? We've got to subtract that out. So the whole area is going to be 12 minus 2 is 10. And then you've got 6, right? And it's below, so 10 times -6. And then you've got to subtract out the semicircle. Well, the area for that, I'll put that in blue. So for a circle, it's pi r squared, right? So it'd be pi r squared over 2. The radius is from -6 to -1, so that'd be 5. So pi times 5 squared over 2. 25 pi over 2. So the area, the red area there, is going to be the entire rectangle, which is -60 minus 25 pi. Sorry, it's messy. 25 pi over 2. So that's going to be -60. Wouldn't be minus. I'm so sorry about that. Plus 25 pi over 2, because if you minused it, it would give you too much. So plus 25 pi over 2. since the whole thing is negative, then you've got to add back that amount to get the red area. So sorry about saying that was negative. So that is option C. Okay, I could see one like that being on there. All right, number 12. Number 12 is it's a acceleration. You're given acceleration, you've got to go to position. So you've got to go to s of t. And that kind, this is involves integration. So this is not on the 2020 test. If you started with position and went to acceleration, you'd be taking derivatives. That could be on the 2020 test. But there's no integration, no velocity acceleration type problems where you integrate on the 2020 test. So, all right, you get to, although, you know, it's too bad because I know you know how to do that. All right, we are getting close to the end of this video. So number 13 says y is equal to cosine x minus the natural log of 2x. We want to find the third derivative. So that's just y triple prime. Okay, we'll just got to power through that. So y prime, what's the derivative of cosine? It's minus sine. What's the derivative of the natural log of 2x? Well, it's going to be 1 over 2x, right? So minus times the derivative of 2x, which is 2. So the 2's will cancel, and you have minus sine x minus 1 over x. So I'm going to rewrite that as minus sine x minus x to the minus 1. So what is y double prime? Well, the antiderivative of sine is cosine, so the antiderivative of minus sine would be minus cosine. And then negative 1 times negative would be plus x to the minus 2. So we'll rewrite that as minus cosine x plus 1 over x squared. Actually, I'm not going to rewrite it like that. Let's just leave it like this since we're going... We'll leave it like this. That'll be easier. And y triple prime, we'll fix it on this third one here. Okay, the derivative of cosine is minus sine, so the derivative of minus cosine would be sine x. So that already takes out b and d. It's got to be a or c. So that would be minus 2x to the minus 3. So that's sine x minus 2 over x cubed. Which one is that? That is A. Yeah, you might have to do something like that. Who really knows? All right, so number 13, good to go. Number 14, you could definitely, I believe you will have to interpret the graph of a derivative. All right. However, what they're asking, I don't think will be asked. So instead of what they're asking, let's ask a different question on number 14. So number 14, we have this graph. Let's say not only is it a graph of f, it's a graph of g prime. Okay, if it's a graph of g prime, what do we know? Okay, so let's say that graph is graph of g prime. What do we know about g? Well, we know that g is increasing where g prime is greater than 0. So where's that? Okay, that's going to be at from 0 to 2. And from 5 to 6. Okay. G is decreasing where G prime is less than 0. Well, where's that? Well, it's from 2 to 5. Okay, you could write them as intervals like this as well. Where do we have critical points? We have critical points where G prime is equal to 0. So that's at x equals 2 and x equals 5. Okay, how about maxes and mins? We have a max where G prime goes from what? Positive to negative. So where does that occur? That occurs at x equals 2. We have a min where G prime goes from negative to positive. Where does that occur? All right, that occurs at x equals 5. Where do we have inflection points? We have inflection points where the slope of G prime changes signs. So where do we have an inflection point? Well, at x equals 4. Where's the graph concave down? It's where slope of G prime is negative, less than 0. Where's that? It's concave down from 0 to 4. Okay, so the interval would be from 0 to 4. Concave up, where slope of G prime is greater than 0. So that's from 4 to 6. This is what I believe you will get asked. Much more likely to get asked something like this than what is asked in question 14. So I wanted to go over that. I just think that having to interpret the graph of a derivative is definitely fair game. You may not do it because you only got 45 minutes, but it's definitely fair game. All right, I'm gonna erase. My computers are making all sorts of noises. Get that happy sounds. All right, last one, number 15. So it says f of x is equal to 6 plus cx for x is less than 1. And 9 plus 2 natural log of x for x greater than or equal to 1. It says it's continuous at x equals 1. That's the key. Because if it's continuous, then you know that for less than 1, the left side has to equal the right side. Okay? If it's continuous, there's no hole, there's no jump. So you know that at x equals 1, 6 plus cx has to equal 9 plus 2 natural log of x because it's continuous. So let's plug in 1. 6 plus c times 1 is equal to 9 plus 2 times the natural log of 1. What's the natural log of 1? That is 0. So we'd have 6 plus c is equal to 9. C is equal to 3. That is option B. So what are they asking here? They're asking, do you know if it's continuous, does that mean this side has to equal this side? Okay, and it does because there's no hole, there's no jump at x equals 1. Okay, so that's the 2016 practice test, multiple choice 1 through 15. We'll continue on through the multiple choices on our next video.